when we finished off last time, we ended here at the questions for section 1, and I asked you to complete these on your own, and we'll go over them now. The first question is, why do atoms form compounds? Well, we said that they form compounds to become more stable. So to become more stable by achieving that full outer energy level. What part of the elements join together? Valence electrons. And this is, as I said, this is why we spent so much time in the first unit fussing around with valence electrons, because they're really the key to understanding chemical bonding. Okay, so the basis of all chemical bonding is understanding where those valence electrons are in the families and how many valence electrons each of the families have. Chemical bond is the force that holds atoms together in a compound. And the two ways we said they could do this, they could either do it by transferring, which is an ionic bond. You transfer electrons, one atom loses electrons, the other one gains, so that's the transferring. So like if you transfer money to a friend, you lose the money and the friend gains the money. In covalent bonding, the prefix co means to share, and the atoms are sharing valence electrons. Okay, so either way, by either transferring or by sharing, we're trying to get those full outer energy levels of valence electrons. Now, we're going to focus specifically on ionic bonding first, and then we're going to focus on covalent bonding. So we're going to study in more detail each of the two types of bonds. Okay? So the first part of ionic bonding is to understand what an ion is. An ion is an atom that is a charged atom because it has fewer or more electrons than protons. So when it loses some of its electrons, the electrons are negative, it becomes positive. And when atoms gain electrons to fill up that outer energy level, then they become negative ions. Okay, so ionic compounds form when a metal bonds with a nonmetal. Okay, it occurs when the electrons are transferred. So a positive ion happens when an atom loses an electron. Now remember, the electrons are negative. In a neutral atom, like we studied in the last unit, there's an equal number of protons and electrons. So like you take something like lithium. Lithium had 3 protons and 3 electrons. The 3 positives canceled out to 3 negatives. Now lithium is in family 1, so it's going to lose one of its valence electrons. When it loses that one negative, it will become a positive. And so I put in here that's because the protons outweigh or outnumber the electrons. It becomes a negative ion when it gains an electron. So something like chlorine. Chlorine had 17 protons, and an elemental protein has 17 electrons. In order to fill up that outer energy level, the chlorine will gain 1. That outer energy level that had 1 valence electron will now have 8, and it'll be full, but now it has 17 positives still, the nucleus is the same, and it has 18 electrons, so it becomes a negative ion. So I put in here the electrons or the negatives outweigh the protons, making it negative. They have opposite charges, so they attract and combine. So remember, this is just like magnets. The positive end is attracted to the negative. So we have a negative ion and we have a positive ion, and just like the opposite ends of a magnet are attracted to each other and they pull together, the opposite ends of these ions, or these opposite ions, are attracted, and so they combine. One atom loses an electron, the other atom gains an electron. Okay, they have opposite charges. One is positive, one is negative. The compound's charge, however, is always 0. So the one that gained an electron, its positive charge cancels out the charge of the negative ion, and the whole compound, like salt, for example, NaCl, what we learned about in the first video, okay, that compound is a neutral compound. This makes them electrically neutral because their charges cancel out. Ionic bonding always happens between a metal and a nonmetal. Metals always lose electrons, making them positive ions. Nonmetals always gain electrons, making them negative ions. So remember, the electrons are negative, and this is kind of backwards, so this sometimes really confuses kids. Okay. You think like losing is bad, so it should be negative. But what it's losing are negatives. So when you lose a negative, you become more positive. Over here, you think like, well, gaining, that's good, but what we're gaining are negatives, so it makes them negative ions. This forms an ionic bond because the oppositely charged atoms or ions are attracted, so they join together. Okay, now, I'm going to take a look at this. Okay, so what does all this mean? Let's go back to the periodic table. And we know that on energy level 1, hydrogen had its one little valence electron, and then helium over here with its full outer energy level of 2. And the first period, or the first energy level, is different than all the other ones. And then everything in family 1, all these alkali metals, all had one valence electron. And I put them here in red because I wanted them to stand out. And everything in family 2, beryllium, magnesium, and calcium, all had 2 valence electrons. And I put them in red here because I wanted them to stand out. And in family 3, we learned that family 3, they all had 3 valence electrons. Family 4 all had 4 valence electrons. Family 5 all has 5 valence electrons. Family 6 all has 6 valence electrons. Family 7 all had 7 valence electrons. And everything else in family 8, except for helium, had 8 valence electrons. Now what happens during bonding? These electrons are lost. You see how I erased them? Well, when we do that, lithium has 3 protons, has an atomic number of 3. But it only has 2 electrons that are left. So it's going to become positive by 1. These elements, in order to get full outer energy levels, so beryllium is going to end up with a full outer energy level and be like helium, just like lithium has a full outer energy level of 2 and it's like helium. Sodium has a full outer energy level of 8 when its electron got lost and it's like neon. Okay, these elements will lose those 2 valence electrons. Now, the valence electrons that family 1 lost don't just disappear. Okay, they're gained over here by the elements in family 7. So I erased them over here, and I added them in over here in green. So there's the law of conservation of mass. They just don't disappear. Okay, and when they're transferred, these lost and these gained. Okay, now fluorine has a full outer energy level. 1 plus 7 is 8. Chlorine, 1 plus 7 is 8. Bromine, 1 plus 7 is 8. But they gained a negative. Okay, they were balanced when it had 2 plus 7 was 9. This was balanced when it had 2 plus 8 is 10 plus 7 is 17. With this extra 1, it has a charge of -1. So it becomes a -1 ion. Okay? Family 2 loses those 2 valence electrons and becomes beryllium, now has a full outer energy level and it becomes like helium. Magnesium has a full outer energy level and it becomes like neon. Okay, and so on. Calcium has a full outer energy level of 8 when these are lost, okay? But when it lost those 2 electrons, okay, -2 and the +4 protons means it has a +2 charge, okay? It's not a neutral atom anymore. Magnesium is not a neutral atom anymore. It has 10 electrons and it has 12 protons, so it has 10 negatives and 12 positives, so it's going to be a 2 positive. Okay, now these electrons didn't just disappear. They get transferred. Remember we said some lose. These lost their electrons and some gain. Well, where they're gained over here, these elements needed 2 electrons to fill up their outer energy level. So we see this oxygen has 2 plus 6 is 8, and sulfur 2 plus 6 is 8. Now they have full outer energy levels, but they have an extra 2 electrons. That's going to give them a charge of -2, so they become -2 ions. So remember we said in ionic bonding, some elements lose, they lose negatives and they become positive. Some elements gain electrons, they gain negatives, and they become negative electrons. These numbers I'm putting up here at the top in red and in green, these are called the oxidation state of the elements when they become ions. Same thing with family 3, okay? These 3 electrons are the 3 that are lost, okay? When they lose these electrons, okay, boron now has only 2 electrons, but it has 5 protons. So it's going to end up with a positive 3 charge because it has 3 more positives than it does negatives. Same thing with aluminum. It has 2 plus 8 is 10 electrons, but it has 13 positive protons, so it's going to end up with a charge of positive 3. And see, every element in a family ends up the same way because they all had the same number of valence electrons. So they all gain or lose the same number of valence electrons. And this is why we said they had similar chemical properties and they're going to bond in similar ways. Now these 3 electrons that these elements lost just don't disappear. Okay, they're gained over here by family 5. So I put the ones that were here in red that they lost over here. They popped up, and this is where they're going to gain. And when these elements gain, now they all have full outer energy levels of 8. But they have an extra 3 electrons. So they have 3 more negatives than they do positive charges. So, like example, nitrogen was neutral when it had 2 plus 5. It had its 7 electrons, but now it has 10. So there's 10 negatives and there's only 7 positives, so it becomes a 3 negative. And these numbers up here that I just put and I showed you where they came from, these are called, again, the oxidation states. Okay, and it's because some elements lose electrons and other elements gain electrons. Family 4, it's going to be special. This is primarily where covalent bonding happens. Because it gain 4 or lose 4. They never lose or gain more than 3. So